Today's topic is pyramids. So we're switching from prisms to pyramids. Now, a couple big differences between pyramids and prisms. The biggest one is a pyramid only has one base. A prism had two bases, a pyramid only has one. So if I look here, I just have the one base. The base is a non-triangular side. We still have a height. The height is the height from the base, perpendicular from the base to the vertex of the pyramid. And whether it's a right pyramid, where the center, the vertex is directly over the center of the base, or it's what we call an oblique, or one that's kind of slanted to the side, the height is still that right angle distance. Now, as hopefully you're figuring out through your reading and stuff like that, and maybe if you had a chance to do the exploration, the volume of a pyramid is still base area times height, but because we slant up the sides, we're actually getting a third of the volume of the corresponding prism. Okay? So let me say that again. If I had just some sort of a prism, I'm just going to draw a really quick prism here. Okay? So let's say I had a prism. Okay, let me clone this here so I can get a really good picture here. There we go. Ah, see, I would have been off. That's why we clone. Okay? So I know it's going to kind of, because I'm not using dashed lines, the picture may flip around on us a little bit as you stare at it, but that's okay. Okay? I know the volume here. I've got two bases. I've got base area. I've got height. And the volume is base area times height, right? Put that in a different color. Call that base area. If I turn it into a pyramid, okay, I've got the same height, I've got the same base area, but you can see most of that volume is gone. The pyramid doesn't contain half of the volume of the prism. It only contains a third, exactly 1/3. So my volume is going to be base area times height divided by 3, or 1/3 base times height. So that's what's going on with pyramids. But for the most part, our technique does not change. I still need to know this basic thing. In order to find the volume of a pyramid, I still ask the same 3 steps. What is the base? Find the area of the base, find the height, multiply the base area times height, and the only difference here that we get from prisms is and divide by 3. We got to remember to divide by 3. With pointy, we divide it by 3. So let's take a look at this pyramid. What type of shape is the base? In this case, the base is my right triangle. Find the area of the base. Well, right triangle is pretty easy because, again, it's basically length times width, or leg times leg divided by 2, base times height divided by 2. So it's 4 times 6 over 2. 4 times 6 is 24, divided by 2 is 12, and give it squared. Context, meters squared. The height is the distance from the base to the vertex at a right angle of the prism, and that's given as 9 meters. So my volume is simply 12 times 9, and then divided by 3. And we can do the divided by 3 first, or we can do it after the multiplication on the top. It's really up to you. Either way, we wind up with 36, and then give a context, meters cubed. So 12 meters squared times 9 meters divided by 3 is 36 meters cubed. That's how we find the volume of a pyramid. So if you're used to finding the volume of a prism, this really isn't that different. All right, you give one a try. I gave you a pretty easy one. We've got a square-based pyramid here. So I'm going to lay out your steps here. Shape of the base. I already told you it's a square. Then you're going to have to find the base area. Okay, you're going to have to find the height. which is given at 12 centimeters, and the volume. So you tell me what the final volume is, that's your question. Number 2 here is a hexagon. So again, the shape of base is a regular hexagon. Okay. The base area, and this is one of those special formulas that is on that review podcast. So once again, if you're kind of procrastinating doing that, you're making it very, very, very difficult for yourself, especially for a hexagon. I think it's a hexagon. 1, 2, 3, 4, 5. Yep, hexagon. If you are going to go back and try to do SOHCAHTOA and find the area of a regular polygon with this, that's going to make this a very long problem. But if you know those special formulas, you know very quickly that the base area of a hexagon is 3 times side squared times the square root of 3 over 2. Okay, 3, 2, 3, 2. And the length of a side is 12, so 12 squared is 144. So 3 times 144 times the square root of 3 over 2. And just the 3 times 144 divided by 2 is 3 times 72, because 144 divided by 2 is 72. Should be 216. Root 3 and its centimeters squared. That's my base area. My height is clearly given at 20 centimeters. So my volume is 216 root 3 times 20 divided by 3. And 216 divided by 3 times 20 is 1,440 root 3 centimeters cubed. And we can keep that one in exact terms of root 3. There's no decimals involved, so we don't need to approximate the square root of 3. We can be precise. Okay? So there's our volume. Okay, a pyramid. I'm not sure even how to pronounce that guy's name, but probably one of the pharaohs of Egypt. He had a height of 144 meters and a volume of 2,218,800 cubic meters. Find the side length of a square base. So you've got a square base pyramid. Okay. And here's my top. Okay. We're looking for the base side length of the square base. We know the height is 144. And we know the volume equals 2,218,800 meters cubed. So what do we have to do? Well, again, we've done this before where we have a different unknown. We kind of work it backwards. My base area I don't know. My base is a square. We know that. So the area is going to be simply side squared. Okay? The height is 144. And the volume is base area, side squared, times the height, divided by 3. But we know that that volume is 2,218,800. So I just have to solve for S. Well, how are we going to do that? That's just algebra, folks. I'd start by undoing the division by multiplying both sides by 3. So S squared times 144 equals, well, it's a big number, 22,800 times 3 is 6,656,400. I'm going to divide that by 144 now. Is 46,225. To solve the squared, I don't want the squared, I got to take the square root. So I take the square root of that answer, and it's exactly 215 Now I know the length of the side. We aren't going to guess and check that, folks. We have to use our formula and use our system to solve for the unknown, and we have to do some algebra. But again, we are getting very, very, very close now to being in Algebra 2. So that type of algebra is stuff that you really need to be comfortable with solving if you're heading into Algebra 2 next year. Believe me, Big Ideas is not going to spend a whole lot of time reteaching you how to solve an algebra equation like that where you're just solving for s squared. You're going to need to know that. Okay, let's find the height of this triangular period when we're given the volume. Same idea. Okay, my base is a triangle, which means my base area equals base times height divided by 2. It's not an equilateral triangle, but that's okay because we're given a side length and the height of that triangle. So that's 4 times 3 divided by 2, or 6 feet squared. My height is unknown. My volume is 14, which is base area times height, which is unknown, divided by 3. Well, how am I going to solve for height? Same thing we did before. We're going to multiply both sides by 3 to undo the division. Now my numbers are a little nicer here. 3 times 14 is 42. Is 6h. Divide by 6. H equals 7. So the height is 7, and we create the context, 7 feet. So we're just using our formula. The big thing, remember, divide by 3. Finally, one more problem for you. The volume of a square pyramid is 75 cubic meters. The height is 9 meters. Find the length of the square base. So that's going to be very similar to this one. You may want to look at the notes I've posted so you see how I solved this, and then use that to help you solve this problem. Good luck, and we'll see you in class.